Hello, I'm Jonathan Rogers, and I would like to thank you for joining this ENIC 2021 Tech Showcase, titled Enhanced Network Performance, Predict Faults, Prevent Interruptions, and Protect Networks. In this Tech Showcase, I'm joined by Samir Alalat, Head of Innovation and Business Development at Calvatech. Hi, Sam.
Hi, JR, and hello to everybody else, and thank you for joining.
So we're going to look at some technology that Calvatech have recently introduced into the market, and that's specifically PRESense, which is an LV network monitor, and LineSIGHT, a management solution for HV faults. So I'd probably just like to start off and talk about a little bit about what is PRESense and why is it needed.
Thanks, JR. So PreSense is an AI-enabled low-voltage monitor, and the reason why we've put it into the market is because there is a growing need for, in fact, there is almost a prerequisite now for LV visibility for distribution network operators of their network. So when we designed PreSense, we wanted to make sure that it acted as a very good power quality monitor. So the power quality measurements at the Class S standards. We also wanted to make sure that it was future proof. And with that in mind, we've put a whole lot of computational power into the unit. It's got two ARM processors. It's got a field programmable gate array processor, which kind of gives it a real edge computing capability at the substation, and it can be remotely updated. So the kind of potential benefits that I guess that opens up is, you get the visibility of your network health, so how close you are to, a particular capacity, constraint management. It also has really, really high quality signal capture, so it can actually look at the health of the cables and help you drive your asset replacement optimization schemes. And it also has our patented kind of fault triggering capabilities in there in terms of the self and MELF algorithms that we have in terms of being able to locate faults and allow you to really exploit the interruptions incentive scheme and make sure that there is a reliable network for consumers.
One of the things that we talked about before was how we can predict faults and why that's going to be important in the future. Can you tell us a little bit about how we do that prediction and what that means for the network operators?
The reason why that's come about really is because network operators are under increasing strain to manage the network more efficiently. And in order to do that, you need a level of predictability in the network, so you're able to plan in repairs, minimize visits to site, come up with schemes that allow you to capitalize that kind of work and therefore save operational money. So when we designed the PreSense, we'd already been doing what you would call proactive fault management for a number of years, and that is, our devices would detect a particular disturbance or perturbance in the network that it was monitoring, and it would issue something, and our service would issue something called a go locate, which in effect told DNOs where a fault was. I think something in around about 90% of cases to within plus or minus 5 meters of a particular fault, and then the DNOs would go out and fix those faults. What we've managed to do with PreSense is kind of bring that fault trajectory estimation back even further. So even now, when you have sparking on cables, when you have very, very small disturbances indeed, we can provide not only a fault location, but we will be able to provide a time frame for when the fuse is going to blow, and a potential classification of that fault. So whether it's going to be, a transient fault, whether we think it's going to be a permanent fault, a whole lot of other cases. And that allows the DNO really to plan in what they need to do and how they actually handle that fault. It minimizes, like I said, it minimizes trips to site. It means that you're saving on carbon footprint. It means that you're not spending as much money. It means that consumers are getting better value for money and their lights are staying on. So, Jay, are these difficult to install in substations?
No, actually, they're very easy. So when we designed the device, first of all, we wanted it to be able to cover 5 ways in the substation, 5 feeder ways. So on average, there's four in a substation, sometimes five. If you have more than that, it's possible just to install multiple units in the sub. And we have basically some Drummond clamps that are used for connecting onto the bus bars to take voltage measurements. So we have L1, L2, L3 voltage phase measurements. And one of those voltages is also used to power the unit, so you don't need a separate power supply or anything like that. In terms of the current that goes around the feederway, so there's a number of different options, but probably the most regular one that will be used is a set of Rogowski coils, which they're flexible, so they can be opened up. They can be put around sort of the cable tails at the bottom of a feeder and closed up again, so it's very easy to install. With regards to setting it up, sort of for data flow and for understanding where it's installed and where each of what the feeders are connected to, there's a simple mobile phone app that can be used to configure that while on site, and that can be also used to test that we're seeing the voltages and seeing the currents and making sure that it's set up correctly on site.
Great. And then, I mean, in terms of the mountings, is it screw fixed? Is it adhesive? Is it magnetic? I mean, is there a bracket that holds the thing? How does all of that work?
So it's supplied with a mounting bracket that allows it to be either put on a wall or cabinet door or something like that. So, and then there's a little mag mount antenna which will connect onto anything metal. Essentially, you can put it on the top of a cabinet or anything in the substation where you can mount it. So one of the other technologies that I would like to talk about today is LineSIGHT, which is an overhead line fault management system. There's lots of challenges that we get for the HV overhead networks. I mean, the network itself is subject to wind and rain and so on, so we get a lot of network deterioration. Pole rot is a well-known problem. Cracked insulators, storm damage and vegetation growth. So with these challenges, essentially, we can get a lot of intermittent faults on the network, which keep coming back again and again, and they cause trips. They're very difficult to find, and they're a nuisance to customers and can be expensive to deal with. So I think this is where a predictive approach allows us to detect and locate the causes of many of these issues. And in a lot of cases that we've seen before a protection trip or outage has occurred. So a lot of the time we can see activity on the network several days and even several weeks before there's an outage. And using that information, we can actually locate where that is. And so it's possible to, for example, reconfigure the network so that whenever there is an outage, or if it does lead to an outage, that it minimizes the number of customers that are affected.
I was going to say, presumably that has, if you don't do anything, if you don't have that information, that has a negative impact on the customer, correct?
Absolutely, yeah. So essentially more customers would be affected because the protection upstream would operate, and it would mean taking off more customers than may have been necessary if we had reconfigured the network.
And for a longer duration, yeah.
Yeah, with sort of the wait until it occurs or wait until the outage approach happens, then we have to sort of react to what's happened. And it means that, it could be out of hours and we have to get staff out to go there and repair faults and to start searching for the problems. And, if that's at night or in the dark and so on, that can just increase the challenge. So it's better if we're able to go out in the daylight and look for something that we know is brewing and is likely to lead to a fault.
Very good.
So with LineSIGHT as well, we can increase the safety on the network by detecting and locating downed and lowered lines on the network. So things that maybe where a line has fell off a pin insulator, for example, and is hanging down, it's missed one of the poles and is hanging down lower towards the ground.
Yeah. So what does the why do DNOs care about down lines? I mean, obviously there's the disruption to the customer, but it's just a fault, right? I mean,
So when a line is down or lowered, it means that it's down below the sort of the safety zone, and it starts to approach land, property, and where people can be, and that's obviously a great safety concern. So knowing that those are on the network, that there is a down or a lower line that's potentially a hazard or a danger, is very important. And at the moment, a lot of the detection and knowing about this is relying on the public calling in or sending photographs. So being able to detect that sort of real time as it happens or very shortly after it happens is a big benefit, a big safety benefit. So some of the benefits that LineSIGHT will bring is improved operational performance, obviously, and also improved storm response, because we can detect nested faults in the network. Those are faults that occur due to sustaining damage after the initial outage. So, a storm the winds will continue to blow, and the networks will continue to get pummeled, and some of the damage there occurs when the networks are off. And that's important because a lot of equipment that rely on the power being on to detect faults, so fault passage indicators and impedance-based methods, won't work whenever the power's off. So having this nested fault capability is a big advantage.
So how's LineSIGHT powered when the power goes off?
So there's a backup battery in there that sustains the system for at least 24 hours, and it uses a pulse echo type technique on the lines whenever the power's off. So it sends out a little low voltage pulse into the network, and then it looks for reflections from damages, open circuits, short circuits, and those types of things on the network during that outage.
So how does it improve? Does LineSIGHT improve network performance? Does it improve the reliability of the network itself? Obviously, you can identify these faults, but how?
Well, the first thing is finding or detecting that things are happening. There's intermittent sort of perturbations, little changes in the network while it's operating that we can detect early on. So this allows us to predict the problem and also locate issues, whether that be an insulator breaking down or vegetation starting to grow into the line and so on. So by being able to work out where those are and the location of them prior to an outage, it enables either a repair of the network or mitigation techniques such as reconfiguring the network to reduce the CIs and CMLs. If there is an outage, by having this accurate location and having it available quickly, it saves a lot of time, because traditionally maybe people had to go out and what's called walk the line, walk across the country and look at the assets and visually inspect to try and find where the problem is. And that might involve walking several kilometres. So by getting down to within sort of 50, 100 metres or so of where the problem is also a big positive. So with LineSIGHT, there's three key elements. There's monitoring hardware, which is installed out on the network. So typically it's installed on a pole, and it will measure voltage, and near sources it measures the voltage and the current flowing into the network. This feeds back information into an advanced system that essentially uses algorithms to look at that data and provide actionable information. So it's, where are the problems, or where are the problems developing? And then this information, the actionable information, is sent into the control room, which gives real-time visibility of the network and what's going on, and allows control room operators to make better decisions about the network.
So how does what different techniques does LineSIGHT employ to actually detect and locate faults?
So that's quite interesting. So we've used a number of different techniques. And the reason for that is that there are advantages, but there's also limitations of some of the individual techniques that are used for locating faults. And so by using a number of different techniques, it allows us to essentially overlap all of the good bits to get really good coverage for many different types of faults. So we use a technique called the multiple-ended location of faults, which is a system that we have developed that uses voltage and current, essentially impedance-based techniques from the source, but combines that with various voltages from different points on the network. And that requires accurate voltage and current sensors, which we've embedded in the system. But it allows us to get very accurate locations on sort of current-based faults, as it were, line-to-line faults, and short circuits.
Okay.
So we also use travelling wave techniques where whenever there's a problem on the network, a wavefront is sent out in different directions. And by accurately timing the arrival of those wavefronts at the LineSIGHT units, we can triangulate where the problem is. And then we have an active technology used, time domain reflectometry, or more commonly known as a pulse echo technique, where we actually actively send signals into the line and listen for the reflections as they propagate down the network. So by the use of all of these different techniques, we can cover low impedance faults, high impedance faults, and faults also when the network's off. And we can look for characteristic changes in the network, which allows us to detect things like the downed and lowered lines, which is obviously very important.
So, JR, I'm interested. You mentioned before an actual capability of LineSIGHT was to detect a fault before it had potentially occurred. I mean, do you have an actual example of that? A real life situation where that happened?
Yeah, absolutely. So there's an example of Lostock Vernon's circuits where there was a ABS HV broken jumper, and we managed to detect some arcing activity from this for several days and several hours before there was an actual outage. It eventually went open circuit, and part of it went off. But as you can see from some of the waveforms here, that we were detecting traces of this several days before it went. We were able to calculate the distance of around 70 meters to the problem from the nearest LineSIGHT unit. So it was actually quite close up to one of the units, but the fault ended up, it was located at 65 meters away from the unit. So again, it was a very accurate location, and it was possible to do that before there was several hours before there was any outage or before there was any disconnected customers.
That's really, really interesting. So in this situation, then presumably there wasn't any fault current.
So there wasn't, no, and it was actually on the TDR, the pulse echo traces, where we were able to pick up the activity. So there was a little bit of arcing, just due to the sort of going open circuit, but there was no short circuit fault currents in this case. So it wouldn't have tripped, for example, FPIs or anything like that. Wouldn't have been able to see this.
So, JR, before when I was talking about PRESense, I mentioned that we employed a number of advanced triggers on the PRESense unit. And I mean, for me, it kind of really differentiates the solution that we have from many others in the market. I was just wondering if you could give us a bit more of a deeper dive into what those triggers are and what they do.
So triggering actually is key to being able to do a lot of the advanced things. So triggering is what we use to decide when to capture voltage and current waveforms at a very high frequency recording level. And the reason that we trigger is not so that we don't produce masses and masses of data with essentially uninteresting things in there. So traditional triggers are things like overcurrents and undervoltages, and more laterally things like spike and step triggers have been put in there. But what we've come to realize is that as we understand more about what's going on in the network and the types of things that are happening on the network, that even more advanced triggers are beneficial. So that could be based on things like harmonics or other sort of computationally intensive things that are done out on site. And to enable that,
possibly a combination or a number of those different factors all working together.
Oh, absolutely. So I think one of the key things is that the unit itself we can remotely reprogram. So we can actually update it with new triggers as we understand more things on the network that we want to see. And this will sort of future-proof us for things that are going to happen that maybe we don't understand at the moment. New emergent technologies that may come out due to advances in power semiconductors and things like that, for example, which can challenge the network from, for example, harmonic points of view. And by being able to update the triggering remotely in the PRESense, that will enable us to basically understand and have visibility of those new things that are happening in the network as they're happening.
I think that's a really important point, really, and it's an interesting way to look at it. I think what a lot of people forget is these LV monitors are going to be installed in the network for potentially the next 10 to 15 years. And
yeah, 20, 25 years maybe.
25 years maybe, yeah. I mean,
unlikely longer.
what you have to think about is the cost of total ownership of the device. You know, the total cost of ownership of the device. So, you know, do you want to be putting something in that does the job for the next 3 years? But then in 3 years' time, you have to go out. 5 years' time, you have to go out. 10 years' time, you have to go out and replace the whole lot because there is a particular challenge that has come along. There's a particular issue that's come along on the network that they aren't suitable for. Or do you want to install something that can, you know, give you access now to what you need in terms of power quality, what you need in terms of access to IIS revenue, what you need?
Absolutely. Absolutely, and I think that's the sort of the big benefit of having a lot of computational power and sort of the having it AI enabled, having machine learning capability up on the device. Essentially, the edge computing and the ability to remotely update that and reprogram it, I think, is absolutely key for future proofing what we're installing now for the next decade or 2 decades. So, do you think with the likes of PRESense and LineSIGHT, the ability to predict and almost, you know, see into the future in terms of faults coming and so on, how do you think that's going to change how you know the operators manage the networks and how they deal with problems that are coming compared to what they do now?
It's an interesting question because obviously the sector as a whole is very technology driven, and rightly so, because technology unlocks the ability, it unlocks the capability to do something about these issues. But it's no good if you don't adapt your processes to work with this new technology. So what we've been doing over a number of years is working really, really closely in partnership with DNOs to enact a proactive fault management service. And that was just based off our current technology that we've had in the field for a number of years. I mean, Bedoings have been there for over, a decade. WeZaps for the past 5 years. Is that right? 5 years?
Yep. Yeah. 2013, so it's almost 10, but...
All right, okay. So... and those kind of changes, those processes have helped the DNOs to save a lot of cost in managing their network, and it's going to be the same with once we move from this proactive process of managing faults to a predictive way of managing faults. And I guess what we mean by predictive is, you know, this is telling the DNOs you are going to have a fault in 8 days with a confidence of, 75%. It's going to be a single fuse blow. What would you like to do about it? And then that gives them the ability to plan an entire process around how they manage that fault. Do you go and put a recloser on there to make sure that there is, only a very, very short interruption to the customer and see how the fault develops? Do you book in a repair crew who then go and find the fault using the pinpointing to use the go locate to pinpoint the fault and repair it ahead of time before it blows, before it goes, before there is an unplanned interruption to the customer. So adapting those processes, bringing the entire workforce along with these new technological changes is vitally important because it changes the way that they work. Ultimately, it makes their job easier. Yeah, it makes the job of the operators themselves easier because it gives them an accurate fault location. It gives the the guys who are actually planning the work and managing the resource. It gives them an easier job because it allows them to profile and react to where they need to put resource well ahead of time. And that in turn allows the entire DNO operation to run much, much more efficiently and reduce operational costs.
Samir Alalat, thank you very much.
Thank you, JR. It's been a pleasure talking to you.
It's been great fun.